Welcome to Inform's What's Your Story series. I'm Kara Tucker, the editor of ORMS Today and Analytics magazines here at Informs. I'm joined today by Ruslan Shaydulin. He is the executive director and head of quantum engineering at the Global Technology Applied Research Center at JPMorganChase. And he's been an Informs member for about 5 years now, right? Yep.
Yeah.
Thank you so much for joining me today and taking time out of your day to talk to me. I'm excited to get to know you a little bit better. I'm going to start with, since it's February, do you have a favorite winter sport to watch or participate in? Want to share?
Well, I do enjoy skiing. Actually, we're based in New York, and in upstate New York, there's a lot of very nice ski spots. Even some things that are, a couple of hours drive from the city, so you can really make a day trip out of it. And it's not like mountains,
yeah,
but it is nice. It's big enough. You can really, get a good slope going.
Have you skied since a young kid, or was that something you picked up as an adult?
I only learned to ski in college. I actually learned in this indoor skiing tube.
Interesting.
Yeah.
Never even heard of that.
So
Where was that located?
It was back in Moscow where I'm from.
Oh, okay.
Actually.
That makes sense, I guess. I didn't learn to ski until I was in my mid-20s, and I still don't really know very well how to ski. So pizza and French fries is what I remember from that. So let's talk about your career in Informs now. Tell us what initially attracted you to the field of ORMS and when you discovered Informs.
Well, I was really interested in optimization, even as a kid. I think one of the things, I was sort of doing this math camps as a kid, and one of the things that really interested me was, things like geometry, graph theory, which is a lot of graph problems are really the kind of problems that, folks here in this community work on. So I really, for a long time, have been fascinated with this.
Yeah.
And I ended up, during my PhD, working on graph partitioning, hypergraph partition, so very connected problems. And that's sort of when I came to Informs, though I think I only came to Informs later, actually, when I started working in quantum computing. So I think you mentioned 5 years, but I've been in this field much longer than that.
Okay.
Yeah.
So you were not a student anymore when you joined by that time. A lot of people get, the recommendation from professors to look into Informs. So how did you find us?
I think SciAm was my bigger home when I was a student.
Right.
And Informs, when the quantum computing community in Informs started sort of arising, that's when I got involved.
Yes. Oh, great. Good. We're happy to have you here. What advice do you have for students in this field as they're nearing graduation or beginning their career journey? Since you've moved up quickly, it seems. So what would you say?
Well, I think one thing that I personally did not appreciate enough when I was a student is the kind of diversity of the career paths that are available for folks. I think a lot of people think a lot about sort of the standard academic track, which is, PhD, postdoc, professor, but really there's all kinds of things you can do with this degree, and people take very different paths in more research roles and more industry roles, product roles, and all of those are things that where your work really takes advantage of your, even PhD in ORMS. So I think that's kind of the main thing in my mind, to keep an open mind to different opportunities that are out there.
Yeah. How would you say Informs could best make sure that people who are maybe on an academic track mindset are aware that there's a whole nother path?
Well, I think, actually out of all societies that I have been involved in, including, SciAm, APS, because quantum is this weird intersection of many things.
Yes.
I think Informs does an exceptionally good job of highlighting industry.
Yeah.
So annual meeting, which is in the fall, is sort of maybe more academic in some ways. But the analytics meeting in the spring is really like an industry first, practitioner meeting. And so I imagine students who go to those actually get exposed to a lot of stuff that is ORMS in industry rather than, just more like research.
Yeah. And then, of course, we have the Edelman competition, and those stories are always fascinating. Thank you. You've only been a member for about 5 years. What's been your favorite experience so far at Informs?
I mean, honestly, I think annual meeting is a very kind of exceptional event. It's big, but not too big.
Okay.
Sort of everybody comes, but it's not overwhelming. And honestly, I think the way Informs organize the annual meeting is very successful. The way kind of the talks are primarily invited leads to, I think, pretty high quality of talks. So I always enjoy.
I think you might be one of the few people to say it's not too big and not too overwhelming. Most people say when they first come to an annual meeting, it's like they don't know where to go, what to do. There's a lot of concurrent things happening, obviously, but it's optimizing your schedule, right? So let's talk all things quantum. Why are we hearing about quantum optimization now? You said you've been in this field for more than the 5 years that you've been here at Informs. So why is this, coming up now? And what's the next buzzword after AI? Do you think it's quantum?
Well, I'm personally very excited about the potential of quantum computing. Fundamentally, quantum computing is a different computational paradigm. So even from very theoretical perspective, you find kind of fundamentally different things that are, provably impossible classically.
Right.
There are examples of, even unconditional resource separations between classical and quantum. So that gives a lot of intuition that maybe there's a lot of potential there. And in addition to this very theoretical kind of perspective, I think recently there's been immense progress in both building quantum computers to the point where now I think we can almost, I personally have a lot of confidence that they will be built, large-scale, fault-tolerant quantum computers capable of solving really industry-scale problems will be built. And on the other hand, the algorithms have also advanced a lot. If you look at the state of the field, even 5 years ago when I joined, I think we didn't have that many actual quantum speedups. There's been a lot of quadratic speedups based on the Grover's algorithm, and you can apply them to many classes of algorithms. But now we have much higher degree speedups, and we even have some evidence that maybe there is exponential speedups for optimization, which is, I think, quite exciting.
Yeah. Are you building quantum computers? Are you allowed to tell me that?
No, we're an applications group and algorithms.
Got it. Okay, just checking.
But we work, of course, with many folks building quantum computers.
Yes, and they're doing it, and they're bigger and faster than ever.
I think it's quite exciting. I mean, it's almost impossible to find a metric on which there has not been an exceptional progress, orders of magnitude in the last few years.
That's great. That's exciting. So you mentioned you love math growing up and still, I assume. So how did this passion for mathematics lead to your career in quantum research?
Well, I actually ended up in this field almost accidentally.
Okay.
When I started grad school, I actually was working on purely classical things. I started working on this kind of obscure problem called hypergraph partitioning.
Okay.
It arises in VLSI design and data distribution and distributed systems. And a lot of what I did was actually writing high performance C++ code. So it's almost like a supercomputing world.
Okay.
At one of the conferences, I met Yuri Alexeyev, who's become a great mentor to me and was in my PhD committee. And he really introduced me to the world of quantum computing. And so I did an internship at Argonne National Lab. And that's sort of how I got started in quantum world. At the time, there was a lot of people felt that the classical supercomputers were really running out of runway, that the energy requirements of classical supercomputers were such that you could not really imagine them growing much in computational power because you're already maxing out an entire power station requirements. And so there was a lot of interest in exploring alternatives, and quantum was one of them, and that sort of very much piqued my interest.
Okay. Tell us a little bit more about yourself. What interests you have outside of work that might surprise someone that's not math related?
Well, I'm a bit of a film buff. I really enjoy the movies. And New York is a great place for that. There's kind of to mirror the Informs spring, fall. We have also in the spring, there's Tribeca Film Festival, and then in the fall, there's New York Film Festival.
Okay.
And they really bring sort of very exciting cinema from around the world, and people come in person. So I really enjoy. And a notable part of my wardrobe now is Tribeca swag.
Oh, nice. So, that's fun. That's cool. What's your favorite one you've seen lately? Favorite film?
I really enjoyed Jafar Panahi's latest film. It Was Just an Accident.
Okay. I don't know that one. I'll have to look it up.
Very kind of powerful story of, on the one hand, wanting to seek revenge, on the other hand, kind of forgiveness and coming to terms with the past. Okay.
Take a look. Thank you. Tell us about your goal to make early fault-tolerant quantum computers useful for finance, and what does this mean?
So maybe we can just start. I mean, this is a great question. This is kind of a mouthful. Maybe we can start with just the words themselves.
Yes, please.
So by fault-tolerant, by early fault-tolerant, right? So by early fault-tolerant, I mean specifically quantum computers with, let's say, hundreds of logical qubits, right? And depending on the platform, that could be even as few as thousands to tens of thousands of physical qubits. The reason I emphasize this as a target is because I really don't think it's necessary for us to wait for quantum computers that are so with millions of physical qubits, really large scale, to do something useful.
Okay.
I'm really quite optimistic that we can do something useful much earlier than that,
okay,
with smaller resources. And of course, the application domain that I'm most excited about is finance, which includes optimization. A lot of the algorithms that we look at today have resource requirements, currently that are maybe in this regime that is not yet early fault tolerance. So we do have some work to do, but I'm quite excited about bringing down that resource requirement.
Okay, thanks for explaining that for those of us who are not in the quantum computing field. You are also on the Informs Quantum Computing and OR Ad Hoc Committee, which is still pretty new at Informs as well. So just tell us about your role on this and what you hope the committee is going to achieve in the next year or so.
So we only had our first year, I think, as the committee, and it's quite exciting. It's really a group of exceptional individuals who are working at this intersection of, on one hand, quantum, on the other hand, operations research. And it's a very nice group of people because I feel like they really represent a kind of diverse set of people, diverse set of stakeholders involved in this area. So I'm quite happy about being part of that. Okay.
Any good discussions that you guys can share?
Well,
it's all closed door.
Maybe
maybe soon. Maybe you'll write another article for ORMS today because there was one talking about the committee itself and quantum. So we can get another one in the magazine, right?
Yeah. Well, the committee got a lot done, I think, this year.
Okay.
We had all the sessions at different events, including at IEEE Quantum Week. Okay. Also optimization sessions or 2 workshops organized by members of the committee. There was, of course, the piece in ORMS today. Yes. So, hopefully more of the same.
Perfect. Thank you. So tell me, if we were sitting here a year from now celebrating what a great year you just had, what would we be celebrating?
Well, I really would like us to have like a rigorous and robust quantum speed up, for financial application. That maybe is a little bit too ambitious for a 1-year timeline. But I would be very happy if we made some notable, measurable progress towards that goal. Okay.
How about personally, anything fun that you want to have achieved in the next year? Climb Mount Everest or downhill ski faster?
I've been walking my squash backhand.
Oh, okay. There we go. Perfect. You can perfect that in a year's time. Tell us how you use AI in your daily life.
Well, I use it all the time. Yeah. We have inside JPMorgan this tool called LM Suite.
Okay.
Which is sort of, you can think it almost like as a kind of a chatbot that's specific to the financial services. Okay. And it has a lot of the same very powerful LLMs inside of it. And I really use it daily, all the time, even for something as simple as, writing emails all the way to like actual, helping with research, understanding papers and so forth.
Do they encourage you to use it daily?
It's a great tool. I don't think...
I know it informs where, we want to be at the forefront of AI and now quantum. So we're trying to use AI more too, because that's what a lot of our members are doing. So my last question is, if you could have dinner, I could be there too, maybe, but with one famous person from history, who would it be and why?
Well, I guess if you're on the list, then the answer is obvious. Yes. Okay, but jokes aside, it would probably be Jonas Bell of Bell theorem fame. Okay. I think I have always been fascinated by quantum fundamental foundations and these arguments about what is the nature of physical reality, because it is, at the end of the day, we want to do more than just shut up and calculate. We want to understand things. And, I think you brought really like an interesting perspective to it.
What would you ask him?
Oh, that's a tough one.
Too many things?
Yeah.
Yeah, you just have a good conversation, I'm sure. Thank you so much for all of your candidness today and telling your story. Thank you all for watching. Don't forget to subscribe to the Informs YouTube channel so you don't miss any of our wonderful video content.